right, we will be looking at the effect of increasing temperature on the rate of reaction. Okay, so the temperature, right, of the reaction mixture, right, between the enzyme and substrate, it indicates the amount of kinetic energy that the molecules have. Okay, so the higher the temperature, meaning higher the kinetic energy, the faster movement of the enzyme and substrate molecules. Okay, so when they move faster, then of course they will bump into each other more, and therefore increase the number of effective collision. However, right, when the kinetic energy is too high, as what you have learned before in proteins, there would be strong vibration of the atoms, right, within the enzyme or substrate molecules. Okay, so more for the enzyme, which are proteins, when there is excessive vibration of the particles in the enzyme molecules, it will bring about denaturation, right, as you have learned before, because the ionic hydrogen bonds are disrupted by the excessive vibration. Right, so that would cause the rate of reaction to decrease. Right, so in the gist, this is the effect of the increasing temperature on the rate of reaction, but we shall look at it again, right, with a bit more details. Alright, so let's start with the low temperature, right? So when temperature is low, right, meaning that the kinetic energy is very low in the enzyme and substrate molecules, they are not really moving much. So if they are not moving, then they are not going to bump into each other, and that means they will not have, or they will have very few effective collisions, and therefore forming very few enzyme substrate complex. Right, then obviously the rate of reaction would be very low. Right, so when the temperature is low, right, when reaction is really not occurring, the enzyme is described as being inactive. But when the temperature increases, right, that's increase in kinetic energy, and therefore, right, increasing frequency of effective collision and forming more enzyme substrate complex, and then the rate of reaction would increase. And for every increase in temperature of 10 degrees Celsius, the rate of reaction would double. Right? This is known as the Q10 phenomenon. Okay, and this would occur, this increase in rate of reaction will occur as the temperature increases until the optimum temperature. Right? So the optimum temperature is the temperature in which the rate of reaction is at its maximum. Beyond the optimal temperature, when the temperature continues to increase, the rate of reaction would decrease drastically. Right? So if you look at the decrease, right, it is much more steep compared to the increase prior to the optimal temperature. Right? So the decrease in rate of reaction is more drastic compared to the increase, and that is due to the denaturation of the enzyme, as we have talked about earlier. Okay, the high kinetic energy causes the excessive vibration of the particles in the enzyme molecule, and the enzyme molecule is denatured. When there is denaturation, right, the overall conformation of the enzyme is changed and not maintained, and that would also cause the loss of the shape of the active site. So the active site is no longer maintained, it is no longer complementary to the substrate, and that would in turn hinder, right, the effective collision and formation of enzyme substrate complex. So due to the denaturation, right, enzyme substrate complex is formed less, and therefore the rate of reaction is decreased. Okay, so for the optimum temperature, right, for most human enzymes, it is near the body temperature, but there are enzymes found in certain bacteria which are heat resistant, and they do have very high optimum temperature. Okay, so some of these bacteria are found in like places like hot springs or deep sea hydrothermal vent, near volcanoes, and all that, right? So there's a question in the notes, right, that asks you, how these enzymes are able to withstand such a high temperature? Okay, so take some time to think about it, and you can do the question in the SRS.